All right,
What
yeah,
is their
this is
website?
our group. This is our website, and it is a cancer detection model. So yeah, you can scroll now. So after brainstorming a lot of different ideas for what we wanted to do over these 3 weeks, we decided to go down a medical route. AI has a bunch of different applications, and we decided to use it to detect cancerous tissue in cells. Metastatic cancer tissue is poses a very large health risk to patients who have it, and it can spread throughout their body really easily. And our AI can identify if someone has metastatic tissue in their cells. Down here is where we're going to test our product. We're going to get to that later. But at the bottom first, we're going to see if you can identify if cells have metastatic tissue with your own eye. And I'm going to tell you right now, you cannot. You can probably try to guess, but you're probably not going to be able to get it right. So now we're going to go to our model and test it out.
Right. So, if you guys didn't see, this is our tester project button. Let's run through some cancer images. So come here to downloads. Let's see. So I'm gonna upload a picture of a cancerous cell. So there are cancer here. So you can see, characterized with this red box, and the cutoff ME. This stands for metastatic tissue. They predicted it with 78% confidence. So I think that's a pretty good outcome. You guys want to try another one? Let's see. Let's try this one. Takes a while to load. And yet again, it finds a different one with metastatic tissue. And so that is how it works. We feed in a lot of cancer cells, and it can either classify them as healthy or metastatic. Now, for example, we do have slight problems. So it's kind of seen. So like, I'm just gonna upload a picture of homework. Let's see what that is. Healthy cell tissue. Damn. All right, well, you can see homework is okay. I was hoping it'd classify it as cancerous so I could legally say homework is cancer, but I can't.
Was that chemistry homework?
Yeah, this is from like 2 years ago. I just randomly went in there and clicked something. So yeah, although sometimes it can miss, our model can miss, and it can have a lot of false positives or false negatives, as you can see here from the confusion matrix, where it's metastatic tissue, but it classifies it as no detection or, so basically what happens here is our model, it works well, but at the same time, we didn't exactly train it to the extent which we needed to. The time constraint placed upon us didn't allow us to, perfect this model. So, that kind of leads to a few anomalies, which would result in homework being classified as cancerous or other things being classified as healthy when they're not even pictures of cells. So yeah, you can see that our model performs really well when it comes to classifying healthy and not so well when it comes to classifying everything else. So that's that. You guys want to see our about us page? So this right here is the team. This is Kami. She worked on the front end, and Zoe. She also worked on the front end. They did an amazing job. So congrats to them. Ben also worked on the front end. Congrats to him. Jimmy, An, and me over here, we all worked on the back end and the code. So, and this is our instructor, Aashish. You guys all love Aashish, and Logan. Everyone loves Logan. So yeah, that's, the team, and it was an honor working with you guys. Anyway, I'll pass it off to the people presenting now.
Great design, great design. Can we give them a round of applause,
Okay, yeah. Now that you've all seen the demo of our website, we'll now be going to the methodology and the motivations behind our AI cancer detection project. So an estimated 2 million new cases of cancer will be diagnosed this year in the US alone, and roughly a third of those diagnosed patients will die from the disease. And as we've all been able to tell, it is incredibly difficult to differentiate tissues at the cellular level, even with the experience of a physician. So with computer vision and neural nets basically beginning to take over the healthcare industry with the help of CT, MRI scans, X-rays, and other ultrasound data, we chose a project that we know could have real-world implications in guiding or complementing a physician's diagnosis. Yeah, next slide. Yeah, so starting off with data collection, we obtained our data from Kaggle's open source histopathologic cancer detection dataset, which initially contained over 250,000 files for training and testing, though we only selected 500 due to time and storage constraints. Our dataset was also cleaned beforehand, so the remaining data processing step left for us was just the labeling of the images.
And in terms of labeling, we only had to label 270 out of the 500 for our data set. And these were really small images. They were only 96 by 96. And the bounding boxes were only like a ninth of that image. So we really had to trust the clean data and the model to detect cancerous tissue if there was tissue.
So using YOLO v4, we train our model to sort the input image into different groups that could have metastatic tissue. Through calculations, the group with the highest confidence has a bounding box drawn and displayed on the result page on our website. A note, on the result page, you may notice that there's only one bounding box being displayed, and that's the effect of NMS, or non-max suppression, in which all the bounding box was suppressed, while only the box with the maximum IOU is returned for better accuracy. Looking deeper, we divided the sample images into 3 different groups for training, testing, and validation through a specific ratio. The ratio is 80% train, 10% test, and the remaining 10% for validation.
Of course, we faced some difficulties on our way to finishing the project. Part of it was meshing the front end and the back end. Some of the CSS didn't really match up. That goes with formatting issues. As you maybe saw on the About Us page, like Faris's picture was a little bit different size that we couldn't fix in time, but then there are some bugs in the code, both in the HTML and in the Python, which we resolved before this. And as An mentioned earlier, multiple bounding boxes were being drawn in one area, but we resolved that too. Also, some things we've learned over this whole process is the importance of good data, garbage in, garbage out. If you have bad data, then you're going to get a bad model. How to accurately gauge good performance. So like you can't base everything off of accuracy. You have to go off of precision and recall, and together like F-score is a really good way. We learned some coding skills when we were making the product, and we learned some things about how computer vision works. So we'll field any questions if there are any.
I was gonna say AI products aside, like this design is phenomenal. I don't know, like do you guys agree? Like this is like aesthetically like really pleasing, you know, to see this whole animation, you know, color choices and everything. It's wonderful.
Is it all types of cancers, or is it like a specific type?
It's metastatic tissue, so it's the cancer that can spread throughout your body.
Okay. That's interesting. That probably has like the most real world application of anything we've seen. That's really impressive.